So I'm Daniel Huygens. I'm the cryptography team lead at Proton. And adjacent to that, I'm also very interested in web application security in general. For my presentation, since I was a very late addition, I won't assume that everybody has read the position paper. If you did, thanks. I hope the presentation will still be interesting. But yes, so with that, I will share my screen. So here we go. Yeah, so this is a very early and rough proposal or idea, let's say, that was also discussed in the Web Application Security Working Group meeting in Sevilla last week or 2 weeks ago. And that the working title for now is source code transparency, but even that is still up for debate or change. But yeah, so what's the goal of this proposal, or what do we want to achieve? Basically, we would like to allow or enable web apps to be built that don't trust the server. So, for example, this could be web apps that use client-side encryption to protect all the user's data before sending it to the server, or it could be web apps that don't send any sensitive data to the server at all and process all the user's data purely client side. Um, and Today, this is very hard to achieve because every time you open a web app, the browser loads the source code from the server and runs it immediately without doing any special kind of checks. So even if a web app claims that the user's data is not sent to the server or is encrypted first, it's very difficult for the user to check that. Or even for a security researcher, it's very difficult to check because even if they read the source code that the server sends to a different user might be completely different, right? So there have been at times, well, there have been some solutions to this. The most notable, or perhaps the most well-known one, is WhatsApp built a browser extension that basically checks the source code. It checks that the source code is signed by a third party, in their case, Cloudflare. So this basically brings the number of trusted parties from 1 to 2, or in a sense that both of those parties would need to collude to send a malicious version of the source code to a user, right? And then a security researcher can go and check the source code that was signed by Cloudflare and check that it was secure. And there, so I won't go through all of these, but another proposal was binary transparency, which was a proposal by Mozilla, but not for web apps, but for their actual for the browser, so for Firefox, to publish the hash of the binary or updates to Firefox to certificate transparency, which is another transparency mechanism that I'll also get to in more detail. But basically, the idea was to publish the hash of the binary there, so that everybody could check that basically for a given version of Firefox, there was only one one binary, basically. And then there's another related concept, but not exactly the same, which is sub-resource integrity, which basically allows you to give the hash of sub-resources. But this is not sufficient for our goal, because we also want to check the main resource. Basically, the index.html if you load a web app, right? Okay, so what's the idea here of source code transparency? Basically, the idea is we want to publish a hash of the source code to some transparency log, and allow browsers to check the source code that they received when they load a web app against this transparency log, and make sure that basically everybody receives the same source code for a given version of the web app when they load that web app from a domain, and basically allow auditors to check that that source code is secure, and again, that the transparency log is behaving consistently, and that the server is behaving consistently as well, in the sense that it's giving the same source code to all users. And then if any one of those users, including a security researcher, for example, checks the source code and somehow determines that there are no vulnerabilities in it, then that basically proves, let's say, that the web app is secure for all users, which is the goal. And this allows a security researcher to use the, let's say, security related tools that they already have to verify, such as CSP, SRI, but also the topics before, such as SBOMs and reproducible builds, to verify the source code and make sure that, again, the web app is secure in general. So where before an SBOM, for example, could be used by the author of the web app to, you know, see what's in the web app and so on. Now you can well, if we have something like source code transparency, the author could publish the SBOM somewhere, and if you then also have a reproducible build, you could demonstrate, okay, here's the source code on Git or whatever, and here, if you build it, then you get this the build source code, right? And then if you hash it, you can check it in the source code transparency log, and that way you know that the source code that is published there is what we actually distribute to all users, and then you can cross-check that with SBOM and see that there are no vulnerabilities, for example. I hope that makes sense. Otherwise, let me know afterwards. Okay, so then as an aside, there is a certificate transparency, which is an existing mechanism where all TLS certificates are published, and that we could piggyback on top of to also provide source code transparency. So how would we do that? So one concrete idea or way to do this would be to create a signed web bundle of all the resources in the web app. This is also an existing proposal in the W3C. And when you create that, you could send a hash of this web bundle to the source code transparency log, and the source code transparency log could include it in their append only log, together with all the hashes of the other web bundles of other web apps that use source code transparency, and basically build a map of like the domain and the version of the web app to the hash of the web bundle, and then periodically um, publish a hash tree, for example, of all of these hashes, and basically create an append-only chain of these hash trees to make sure that um, um, the hash is included in every um, published hash tree, such that a browser can check, okay, the hash that I receive, or the hash of the web bundle that I receive, is included in this source code transparency log. Therefore, security researchers will also see it, and it's the correct source code for this web bundle. And then we could create an X509, TOS certificate extension indicating that source code transparency should be used and that the browser should look at this source code transparency log, which would then again piggyback on certificate transparency and make sure that whenever you load a web app over HTTPS using such a certificate, that the browser knows, okay, this is a participating web app and I should do this check. And then security researchers can check all the certificates in certificate transparency to make sure that, yes, actually, the web app is using source code transparency, and indeed all other users of this web app will also do this check if they're using a browser that supports source code transparency, right? So yeah, I think that's the main proposal. In the interest of facilitating discussion, I'll list some challenges that are up for debate or up for discussion. So one is, should we allow updates immediately? Meaning, should you be able to ship an update to a web app immediately, same as today? Or should you wait until it's included in the log, right? Arguably, even if you wait until it's included in the log, vulnerabilities will only be detected once a security researcher actually looks at the source code and detects a vulnerability, right? So perhaps it doesn't matter. Then another point is, if we use the domain, does it mean you can only ship one web app per domain? Or if we use the path, then, the user might land somewhere else on the domain, right? And then, there are details to be discussed. What if you get an error? Clearly, we shouldn't allow the server to just give an error page with completely different JavaScript, right? That would be bad. But also, we can't prevent errors from happening. So, there's interesting details to be discussed. But I'll stop there. So yeah, thanks. Any questions?